Okay, so I'm going over I'm recording. I'm going over chapter 4 and chapter 5, the review that I gave you after the last test. Now, I don't have this up here all pretty, okay? But I'm going to go through these problems. Can I borrow this for a second? Okay? Because some of these are pretty simple. So for the first three problems, for problem number 1, you're given a triangle, and you're asked for each of these three problems to explain whether they're acute, obtuse, or right, and if they're scalene, isosceles, or equilateral. So since all of these angles are less than 90 degrees, this is acute. If these two angles are congruent, then the sides opposite those angles are congruent. So it's isosceles. Problem number 2. This was 95, 40, and 45. None of those are the same. So it's scalene. And there is one obtuse angle. It's obtuse scalene. The last one is a triangle where all three angles are 60 degrees. Okay? Now, a lot of you may not have, or it's okay, I would have accepted a few things here. I would have accepted equal angular and equilateral. If you put acute, because they were all less than 90 degrees, I would have accepted that. But this was the review. I didn't ask you that question on the test. And I can tell you the equilateral, equal angular triangle, not what's on the file. Okay? So for the next set of problems, you have triangle R. Is this the S?
Yes.
T?
Yes. Yes.
Okay? And this says 9x plus 2. And this says 6x plus 8. And this says 3x minus 1. In the directions on this, they tell you that RS is congruent to ST. That means you can set these equal to each other. On your test, the triangle was actually equilateral, right? On the chapter 4 test, the triangle is equilateral. So all the sides were equal, which meant you could just pick 2 of them and set them equal to each other. So the first thing you were asked to do was find x. 9x plus 2 equals 6x plus 8. I would set, so we're just solving. I subtract 6x from both sides. I subtract 2 from both sides. X equals 2, correct? Yes. To find the measure then. Now, when I plug this in, this and this should be the same thing, correct? So 9x plus 2, 9 times 2 is 18, plus 2 is 20. So RS is 20. TS, 6 times 2 is 12, plus 8 is 20. And for the third side, 3x minus 1. So 3 times 2 is 6, minus 1 is 5. On the one you had on your test, when you plugged the x value in, you should have gotten the same number for each side. So I'm also talking about the test because you might, as you're looking at the review, also look at how you did this problem when you had it on a test. So you might want to have out not just your chapter 4 review, but your chapter 4 test. That's why I handed out your folders. Because if you got this right on the review and you got it right when we took it on the test, you should feel pretty good that if I ask questions like this on the final, hint, hint, there are questions like this on the final, you would get them, correct?
Yes.
The next set of problems was using the distance formula 3 times. So you had K was 5, negative 3. P was 3, 4. L was negative 1, 1. So in order to do this, you need the distance formula. Many of you are using the same reference sheet as the last test. And that should be a minus, right? x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So if you're using the same reference sheet as you used before, then you should already have the distance formula. I'm not going to bore you by going through doing this. Most of you, when you did this on the Chapter 4 test, the first page of the Chapter 4 test for most of you is pretty beautiful, meaning like you got this, okay? I will tell you that the answers you should have had. KP was, I believe, radical 53. Is that correct?
Yeah.
Okay. PL was radical 25, which is 5. And the last one, KL, was, what was it, like radical 52 or radical 54? 52. I think they were really close. And they were really close in the hopes that you guys might then be like, wait, they're close. Let me go back and check. Get a little even more practice. And the triangle is a scalene triangle. On PL, I would give credit if you had radical 25 or 5. I'm testing if you know how to do the distance formula. If you still can't plug these in, then I would make some time to come see me in the next day or two. Okay? But I really think that at this point everybody is pretty good at this. Okay? So for the next one, and I'm actually going to try and draw this diagram really nicely. Okay. That goes like that. That goes like that. That goes like that. That goes there. Okay. And this says 1, and this says 68, and this says 36, and this says 2, and this says 3, 70, 4, 5, 118, 60, oh, that's blank, right? This is a 6, this is a 65, this is an 82. So what I would do is I'd make sure I know how to do all this. Because if you didn't realize on your test it was the same drawing, they just asked you different problems. Look at your test. Look at your review, look at your test. Okay? Your test should be in your folder from when you took it. So, how would I find the measure of 1? How would I find the measure of angle 1? It's exterior, right? So I could just add these up. Or I could do 180, subtract these to get this angle here, correct? And then 180 minus this. But if this is an exterior angle, so what's 68 plus 36? Guys, this is your review time, so you should be practicing punching numbers into the calculator.
104.
104. Or 180 minus 104 would be 76. So if this were 76, then angle 1 and 76 are a linear pair, correct? So if you didn't remember the exterior angles theorem, you could use the triangle sum theorem. Now, I don't ask this angle, it's not numbered, but if this is 36, what's this?
36.
Why?
Vertical.
Yay, we're getting vertical angles now. Now, okay, so by the way, 3 is vertical to this, correct?
Yep.
So 3 is 65. So how would I find the measure of angle 2? Add those up and subtract to 180. So I would just do 100 in the calculator. I would just do 180 minus 36 minus 65, and what do I get? 79. Measure of angle 3 we said was 65, right? So now I want to find the measure of angle 4. So 3, 70, and angle 4 are going to equal 180 degrees, correct?
Yeah.
So I know that angle 3 is 65. So if I start at 180, I subtract 65 and I subtract 70, what's left? So in your calculator, 180 minus 65 minus 70. What?
45.
45, do you agree?
Yes, sir. Yeah.
So this is 45. So there's two different ways I could do 5. 118 is the exterior angle, correct? The measure of angle 4 plus the measure of angle 5 would equal the exterior angle. So if 4, how the heck did I do what? What I just did? Okay. So how the heck I just did this? That we have an exterior angle theorem that says the exterior angle is equal to the sum of the two non-adjacent interior angles. I'm going to do it that way, this way, and I'm going to do it a different way that's a little bit longer in case you don't remember exterior angles. So, this plus this is equal to this. 45 plus the measure of angle 5 is equal to 118. So I would subtract 45 from both sides, and what is the measure of angle 5? 73. Now, let's say you didn't remember exterior angle. This angle isn't numbered, but can I find the measure of this angle?
Yeah.
How would I find the measure of this angle?
Correct.
Subtract from, because they are a linear pair. So what's 180 minus 118? And then if I did 180 minus 45 minus 62, I get 73, correct? So that might be the way some of you do it. Now, to get the measure of angle 6. Angle 6 is exterior to these, right? So the 65 plus the 82 is going to equal the measure of angle 6. What's 65 plus 82?
47.
What? Or I could have done 180 minus 65 minus 82 to get this angle, correct? What is 180 minus 65 minus 82?
33.
And then 33 and angle 6 would be 180 degrees because they're a linear pair. Okay? But the best way to look at these is could you do every angle? Because I think, even on your review, based upon the ones that you were asked, You had to be able to do them all. Sometimes you had to do things that weren't asked to get to the next one. Okay? But I think to get 2, you have to figure out that. Okay? The next 2 were 2 triangles. And I'm already picked those up. Okay. Okay, now it doesn't look like it here, but you're told that this is 108 degrees. So that means this must be 108, correct? And there's one congruence mark here of 48 degrees and one there, correct? And that has the letter Y. So Y is equal to what?
48.
Okay? And by the way, that was the second question in this section, right? So the other one, 2x minus y. So you're going to have to figure out how many degrees this angle is and set it equal to 2x minus y. So how are you going to figure out how many degrees this angle is?
You plug in the
Y.
plug in Y.
Well, you can't plug in y, no, because you don't, first you have to figure out how many degrees. Before you start plugging anything in, you have to figure out here how many degrees.
180.
So 180 minus 48 minus 108 gives you what?
24.
So, okay, guys, you need to get this first because you have 2 variables over here. So 24 equals 2x minus y. If now I can plug in equals 2x minus, hold on, I wrote wrong, 2x minus 48. A lot of you missed this. Do you see what on the test? Which means a lot of you missed it on the review. And I don't know how you did when you did it at this review. It looked to me walking around like most of you did not do this review for the second part of the final. And that's okay if you're okay with whatever grade you get there. Okay? A lot of you may feel like at this point, and it may be true, that based upon the first part of your final, your grade is pretty cemented. And therefore, maybe you spent a lot of time the past few days studying for a class that you weren't doing as well in, or that you weren't as cemented of a grade in. That's fine. But I want to make sure you understand. You did 180 minus 48 minus 108 to get that's 24 degrees. You set that equal to 2x minus y. Is there a question? Because I keep hearing you talking. So now what would I do to solve this equation? Add 48 to both sides. What is 24 plus 48?
72.
And then when I divide by 2, x equals 36. Okay. I realize that it's a little difficult because I normally, when I do reviews, have like the pretty diagrams up, like how you have them, and I don't have that here. I have these ugly diagrams. But I think it should still kind of be enough to help you out. The next problem definitely needs a pretty O diagram. So I'm going to try and use my straight line tool and make the prettier diagram. So it looks to me like, oh no, wrong line. Like I have a line like that, like that. There's a point E there. Oh, yeah.
Pretty good.
That's pretty good. This is an A, this is a B, this is an E, this is a C, this is a D. Okay. So the first one talks about AC being congruent to AD. Okay? And I have been saying for a while that you need to understand this concept of opposite angles from sides. The other thing you need to understand is that if you are talking about angles, you are writing an angle symbol and one letter, or an angle symbol and 3 letters. The reason I say 1 letter or 3 letters, if I am talking about an angle with a vertex of D, I can just use the letter D because there's only one angle in this drawing with a vertex of D. I could also call this CDE, correct? Or CDA. If I'm talking about an angle with a vertex of C in this drawing, I have to use 3 letters. Some of you, and it might be enlightening to look at what you put on the test, when I am asking you for angles, are still using 2 letters. 2 letters means a side. Right, you need 3. But I have kids who are still doing, and they'll put the angle symbol even, but they'll put like EC. That's not an angle. Okay? So, but here's why, and a lot of you aren't even looking at what you did. That's why I'm saying, first of all, look at this problem on your test. You should all have in your folder your chapter 4 test. See what you did. Because if we're still giving angle side notations when we were talking about angles, you need to understand that. Okay? So, I am told that AC is congruent to AD. I'm trying to color code this to help. What angle is opposite AC? Not CD. Just D. Just D. Or CDA or ADC. But if some of you, and I actually prefer, a few of you did call out CD. Okay? So I actually prefer that you did it so we can go through once again. If you just called out CD, that's 2 letters. And an angle is how many letters? 1 or 3?
3.
But can I say just 1 here?
Yeah.
Yes, why?
Because it's the only angle with a vertex of D.
Because it's the only angle with a vertex of D. Okay? Now, what angle is opposite AD? ACD. And this one I can't just say C because there's more than one angle. Now, do you notice if this helps you? ACD, right? And the C is in the middle, is opposite what line? AD. And AD is the first and last letter in this angle. So maybe that helps you a little bit. So what angles are congruent? If these 2 sides are congruent, the angles opposite them are congruent. So if I wanted to use 3 letters, for angle D, look, I could use A, D, C, and A and C are the first and the last letters of the side that it's opposite. Maybe that pattern helps you with these, okay? The other one you're asked, so let me erase this all. Okay? The other one you were asked about is BE and BC. Now, BE and BC. Now, the way I've drawn this, BE and BC don't even look congruent to me. Okay? So, I might notice a pattern. I want to find the angle opposite BE. I might have noticed this pattern just now, which means the first letter is going to be B. The last letter is going to be E. What letter's in the middle? C. This angle is opposite this side. Okay? Instead of going straight across from B to E, I go B, over to C, and back to E. Maybe that pattern helps. And then if I look at the other one, which is side BC, my first letter is B. My last letter is C, correct? And I'm going B, but I'm not going right to C. What angle is opposite it? E. And this may help, because if I thought D, well, I can't get from B to D, right? So I'm not going to C, I'm going to E and back to C. That's the angle opposite. And that's what we're doing, okay? I'm going to save you. But I don't think coordinate proof is even on your final. No, it's not. Okay? So in the interest of time and what to study, don't worry about coordinate proof. Oh, thanks, Mrs. Falk. Okay. So, not only thanks for not putting on there, thanks for telling us that, right? Yes?
I have a question about what part I got
Because there's more than one angle that has a vertex. First of all, I'm here. There's more than one angle that has a vertex R and vertex B. Okay? That's 3. And then R, B, T, and again, T. There's more, you're only using one letter here, and there's more than one angle that has a vertex T. Okay? So, correct, those are wrong as well. Now, D is technically okay if only one angle has a vertex of D. Okay. So, again, question just was, student was looking at their test and asking why what they did was wrong. In their case, the problem was that when they were talking about angles and there was more than one vertex at that angle, they were only using one letter. Realistically, it's probably good practice to use 3 letters for all your angles, right? I just don't want to tell you it's always 3 letters because sometimes you might get a proof, and you notice where they only talk about one letter because there's only one angle at that vertex. If I could reinvent geometry, I would make us always use 3 letters all the time for every angle. And then we wouldn't have this confusion about why sometimes one letter, okay. But I'm not a geometry god. I don't get to rewrite the whole subject. And yes, I could rewrite it just in this classroom, but then I wouldn't be preparing you for, like, what else happens. So, on your review, Moving on to chapter 5. Most everybody did really well in the chapter 5 test. Okay? In all of these cases, you were setting things equal to each other and solving. The only problem that I saw anybody run into on the chapter 5 test was not plugging back in. So for instance, for number 1 on the review, I think when you solve, x is equal to 5, and you plug it back in, and kn is equal to 15, correct? And number 2, you would set that x plus, I'm going to just draw one drawing up here for those of you who decide to watch the video at home. Okay. X plus 9, 2x minus 1. You set them equal to each other. You get x is equal to 10, and MFZ is equal to 19. For number 3, TU, you set the 2x plus 24, the 5x minus 30 equal to each other. X is equal to 18. You plug it back in to find TU is 60. On number 4, technically, there's not enough information given. If you look at all of the other 3 problems, they have congruence markings and right angle symbols. You have to have the congruence marking and the right angle symbol.
But there's no right angle.
And there is no right angle, so technically the answer is not enough information.
But what if we were to solve it on the test and just didn't understand?
It would be wrong. But I don't think I trick you like that. What? What? Okay, so the next part of the chapter 5 review talked about medians of triangles. So I would make sure you have in your notes and on your reference sheet something about the medians, because there's 2 different rules here. On the median of a triangle, you have a smaller part, a longer part, and the whole thing. This might be something that you're writing down in your notes here, on your reference sheet. If you have the whole thing, if you are talking about the whole thing, the smaller part is 1/3 of the total, the whole thing. And the longer part is 2/3 of the total. Okay? So, if you are given the whole thing, the whole median, and you're asked to find the smaller part, it's 1/3. If you're asked to find the larger part, it's 2/3. If they give you the smaller part and you're just asked to find the longer part, the smaller part is 1/2 of the larger part. So if you're comparing the smaller part to the whole thing, the smaller part is 1/3 of the whole thing. But if you're comparing the smaller part to the larger part, it's half. If you're comparing the longer part to the smaller part, it's 2 times the smaller. Which also means, so 2 times this, or 2/3 longer. Okay, sometimes if you have the smaller part and you're asked to find the whole thing, rather than dealing with that 1/3 fraction, it's easier, you have the smaller part, the longer part is 2 times that, and then you add the smaller part and the longer part to get the whole thing. So for instance, in number 5, on your review, you were asked to find F to P. And F to P, looking at your diagram, was the smaller part of the entire BF. BF was 39. So if you take the whole thing and take 1/3 of it, you would get 13. You were also asked to find the entire CD. Okay? And you were told that C to P was the longer part, was 30. Rather than dealing with a fraction of the here, I would have said, well, if the longer part is 30, the smaller part is 15. So if I add them all together, the whole thing is 45. Okay? And you were asked to find E to A, which is 54. This one, you were given the smaller part of 18. You were asked to find the whole thing. I would have then said if the smaller part is 18, the longer part is 36, 2 times the smaller, and the whole thing is 54. Okay? So, for the next few, just real quick, because I want to get this video done before we break, you guys go to lunch. Is it possible to form sides of a triangle? So for instance, you had 9, 12, and 18. When you add 9 and 12 together, if you add the 2 smaller sides together, you get what? 21. And 21 is greater than 18, so yes, it is. Okay? The other what numbers you're given were 8, 9, and 17. When you add 8 plus 9, 17 is not greater than 17. So the answer is no.
The answer is yes.
So the last one, guys, a lot of you are messing this up. Real quick. You are given sides of a triangle that are 6 and 19. You want the range of the third side. You subtract them. Check your signs. You subtract them, and what do you get? 19 minus 6 is 13. So 13 is the smallest it can be. 13 is less than x, which is less than 25. On the test, I saw a lot of mistakes with this, with the signs. If you wrote the words out, it's greater than 13, but less than 25. A lot of you wrote less than 13 and greater than 25. Okay? Thank you very much for your time.